Hello guys, so today we are going to start class 9 physics, that is work, power and energy, and this is Anurag Kumar Misra who is going to teach you work, power and energy. Today we will study about what is work, what are the conditions necessary for work, formula of work and many more things. So let's begin with what is work. Work is the product of force and displacement. So we can write product of force and displacement. First of all, we will see the formula of the work and then we will go to the explanation. So from here we can say that product means what? Multiply. So multiply of force and displacement. Force sample is F and displacement S. So we can write product of force and displacement is equal to this. Work is equal to force and displacement, and this is the work. So now we will know that what do we mean by work. So work, when we apply a force on any object and it makes displace, then it is work. For example, you can take from Mahabharat, Ramayana. So when Angad goes to the Ravan and when he asks everybody to shake his leg, all of them were applying force on his leg, but there was no displacement. The leg was not making any displacement, so there was work is equal to 0, because there is a condition that if any of the either force or displacement will be 0, then the work will be 0. From there we got, or another example you can take, that when there was a swayamvar of Sita, so all were asked to break that Dhanush. So all the king were going, but they were only applying force on that Dhanush. And when Ram went, he took that Dhanush and make displacement on that, or took it up. So there was force also and displacement. It means work done is equal to force also there, and displacement means work was done. So Ram had did the work and he got married with Sita. So here we had understand what do we mean by work and the formula of work. Now we will go to the types of work. There are mainly 3 types of work. So we will go that, and that is very simple. So when we do work, either we did work or we didn't. If someone is doing work, he may do it properly. If he do it properly, then it may be positive work, and if he didn't do it properly, then it will be negative work, and if we don't do work, then it will be 0. So not doing work means 0. And I had explained this, that when the work will be 0, when any of thing, either force or displacement, any of the thing is 0, then the work done will be 0. If we take that work is equal to force is equal to 0, then work done is equal to 0. Either S is equal to 0, then work done is equal to 0. So this is 0, work done is 0. Now come to the positive. If the force and displacements are on the same direction, when they are applying on the same direction, as if we are pushing this stone, we are applying force on this direction and displacement is also in this direction, then it means that it is positive work, or the work done is positive. If the work done, force is applied on another direction and displacement is in another direction, then the work done will be negative. For example, you can take this stone. When this stone mass is 5x, and suppose that you are here, your mass is x, and you are pulling this towards you, but having large mass than you, Let's suppose take better example than it. Assume it is a mountain and here is a rock of 5x mass, and here you are standing whose mass is x. There is a rope. Now you are pulling this stone towards you, and because of having large mass than you, this stone will not come towards you, it will go downwards. First thing that it is having more mass than you, and second that there is a slope, so it will not come towards you. It means you are applying force from this side, force is here in opposite direction, and displacement is in opposite direction. So when the force and displacement are in opposite direction, then the work done is negative, and when force and displacement are in the same direction, then the work done will be positive. So I hope you all have understand what are the types of the works, what is work, and what do you know from the formula work is equal to force into displacement. So let's see more example for understanding the work for better. So now we will go to the more examples of the work. As assume that when you are going to school and you came back from the school, but your mother said that you haven't did any work. Why she said that? Because when at the morning you went to the school from your home, this is your home, and you went to the school, this is a school, and you returned from the school to your home. So your position is the same. You at morning you were at the home, and when you return from school, then also you are at the home. It means there is no displacement. There is no displacement. You are at the same position. So we have seen that when the work done, either force or displacement is zero, then the work done will be zero. So here no displacement. That's why your mother says that work done is equal to zero by you. So I hope you have understand this example. For more prefer you can take when you will push any wall, or I will push this, then the wall will not move from its place. Suppose that it is a wall and you are applying your full force of 40 Newton on the wall, but the wall is not moving from its place. It's meant that displacement is equal to 0, so the work done by you will be 0. Okay, now we have not studied about SI unit. So SI unit of work is equal to joule, or you can from the formula work done is equal to force into displacement. We can say also the SI unit of force is equal to Newton, and SI unit of displacement is meter. So one more SI unit we can say that Newton meter. So the SI unit of work is either joule or Newton meter. Now we will go to energy. We have studied all about work, and we will move on to energy. What is energy? So energy is equal, work is equal to energy, or we can say energy is equal to capacity of doing work. Capacity of doing work is energy. Any object that can do work, and that work will be known as energy. So there are many types of energy in our universe, and they did not change. So energy remains same in the world. Now we will see the SI unit of energy. SI unit of energy is same as that work, because work done is equal to energy, and hope you understand that the SI unit of energy is joule, because the work is equal to energy, so SI unit will be also same. Now there are many types of energy that remains in this universe. So there are the many types. We can write sound energy, light energy, heat energy, potential energy, kinetic energy, mechanical energy, and many more. There are more and more energies that we can't say. So we know that these energy are not same, so they remain changing when there is a movement in an object. So from this we can say that the energy that exists in the universe remains same. So from this there we can say there is a law of energy, and that is energy can neither be created, energy can neither be created nor be destroyed, because the energy remains same in the world. It does not go somewhere or come from anywhere. It only changes its type. As if there is sound energy, it may change into heat energy, kinetic energy may change into potential energy, but they does not go anywhere or come from anywhere. So we can say that energy can neither be created in the universe or nor be destroyed. They remain same, as we have studied law of conservation of mass, that mass can neither be created. So that's same, that law of energy can neither be created nor be destroyed. So here I hope you understand law of energy and the SI unit of energy, types of energy, and one more thing, that the mechanical energy, this mechanical energy is the sum of the potential energy and kinetic energy. Means potential energy and kinetic energy together makes the mechanical energy. So I hope you understand this. And now there are describe about this potential energy, kinetic energy, and that we will study later on. So I hope you all have enjoyed today's session. Now we will continue in our next lecture. So thank you.